Introduction. In this experiment, we investigated the electrical resistance of resistors arranged in both series and parallel circuits. Using Ohm's law, we analyzed the relationship between voltage and current by creating voltage versus current graphs. Since Ohm's law follows the same form as a linear equation, the slope graph represents the resistance of the circuit. Materials: 3 resistors. Connecting wires: signal generator, voltage current sensor. Table I, color band code key, first 3 bands: black 0, 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9. Table 2, accuracy color band code key, 4th band: red +, 2%, gold + 5%, silver + 10%, band 1, band 2, band 3, band 4. Theoretical value: resistor 156, 1 10%, 560 resistor 2, 27 1 10%, 270 resistor 3, 39 1 10%, 390. Procedure. Step 1. We connected one resistor at a time in series with the current sensor and signal generator, while placing the voltage sensor in parallel with the resistor. We started at 0 volts and increased the voltage by 1 volt at a time until reaching 10 volts, recording our measurements at each step. Using the linear fit of the voltage versus current graph, we determined the slope of the line, which represents the resistance according to Ohm's law, and recorded this value for each resistor to compare with theoretical values from the color code. Step 2, we discussed as a group which circuit configuration would produce the greater overall resistance and explained our reasoning. We identified setup A as the circuit with all resistors connected in parallel, and setup B as the circuit with all resistors connected in series, preparing to compare how each arrangement affects total resistance based on how current flows through each configuration. Procedure. Step 3. We used the resistance values we measured to calculate the equivalent resistance for both the series and parallel circuits. For the series circuit, we added all the resistances together. For the parallel circuit, we used the reciprocal formula to find the total resistance. We recorded these calculated values so we could compare them to our experimental results. Step 4, we built the parallel circuit and measured the total resistance by recording voltage and current and finding the slope of the voltage versus current graph. We then repeated the same process for the series circuit. After collecting our data, we compared the experimental resistance values to our calculated values and found the percent error for each setup.
It's not curving, like I don't know why.
It's still.
Procedure. Step 5. We tested whether changing the order of the resistors would affect the total resistance in series and parallel circuits. We rearranged the resistors in different orders and compared the results to see if there was any change in the overall resistance. Step 6. We built a mixed circuit by connecting two resistors in parallel and placing the third resistor in series with that pair. We measured the total resistance for each setup and recorded our results, comparing how the overall resistance changed depending on which resistor was placed in series.
Okay, I see a little slant coming.
Data analysis. We experienced technical issues with the equipment that prevented us from collecting complete and reliable data, so we were unable to calculate percent error. We asked the TA for assistance multiple times, but the problems appeared to be related to the materials rather than our procedure, so we recorded the data we could obtain and noted this limitation in our analysis. Conclusion. In conclusion, we used Ohm's law to determine resistance by analyzing the slope of voltage versus current graphs for individual resistors and combined circuits. We observed that when we connected resistors in series, the total resistance increased because the values added together, while in parallel, the total resistance decreased due to multiple paths for current to flow. Our experimental results were generally close to our theoretical calculations within expected tolerance, showing that our measurements were consistent with predicted behavior. Through this lab, we strengthened our understanding of how resistance behaves in different circuit configurations and how linear relationships can be used to analyze electrical systems.